Hello everyone, welcome to K-TechService with Etienne. Today we'll be looking at what these two Kubernetes is all about. I will take you through all the most important components and we'll look at in depth as far as this technology is concerned. So we'll start by looking at what is Kubernetes. So Kubernetes, also known as K-TechService, is an open source orchestration tool developed by Google in Go language, or you can refer to Kubernetes as a container management technology developed in Google Lab to manage containerized application in different kind of environments, such as physical, virtual, and cloud infrastructure. It is an open source system which helps in creating and managing containerized application. Okay, now, before I go ahead, I just want to make sure that you already have the prerequisite as far as Kubernetes is concerned. And the prerequisite being that you must have done containerized application, or you must have learned container technologies like Docker. So for you to actually understand this concept of Kubernetes. Now, for a layman understanding of why we need Kubernetes is because, remember, when we're dealing with Docker, we saw how to create multiple containers, multiple images using Docker. And because of that, if we want to run those multiple images, like let's say 1,000 of those, it becomes so difficult to just be running Docker run, Nginx, Docker run, HTTP, Docker run, this and so on. So because of, and it's very difficult to manage multiple of those images. If you just one or two, then that's fine. But when it becomes like so many, it becomes so tedious to manage them. So because of that, we need a management tool to manage this technology, to manage this Docker. And because of that, we have Kubernetes. So it is a container management tool, container orchestration, and it is open source too as well, and it fits in whatever environment, be it on-prem or on cloud. It fits on any hybrid environment. So that's what Kubernetes is all about. Now, why do we need Kubernetes? Like I said, before the coming of Kubernetes, most applications used to be deployed in monolithic manners. What do I mean by monolithic manner? Monolithic meaning that you build an application in a block. When I mean a block, let's say that you want to deploy a website or you want to build a website. Then you put customer facing, you put you put like the website itself, then you attach it to the whole infrastructure. Then what happens is that that application is being built in a block. And if any of those blocks get missing or there is a problem there, developers need to do some work, then the whole application is a mess. So because of that, the coming of microservice applications, which means that these applications are being built separately from each other or they depend on each other. So because of that, the coming of Kubernetes has helped in solving this problem. Now, looking at this diagram, it best explains what I was talking about. So we have a monolithic architecture on the left-hand side, and we have a microservice architecture on the other side. So looking at the monolithic architecture, you can see that you have the user interface, you have the data access layer, and you have the business logic. All of those makes up a block, which is known as a monolithic architecture. And if any of that block or any of that layer, let's say the UI, there is a problem in it, then the whole block or the whole architecture is in a mess. Looking at the microservice architecture, you see that just one layer, which is a user interface, has been split into various microservices, means it has been split into various subunits, which makes up a microservice. And because it has been split into that, it's very easy to manage using Kubernetes. Now, we'll look at what a Kubernetes architecture is all about. So that's the second phase of what we'll be looking at as far as Kubernetes is concerned. And for you to really say that you know Kubernetes, you should be able to know the Kubernetes concept, some of the basic terminologies as far as this Kubernetes is concerned. So we'll look at the architecture, what makes up a Kubernetes. So now, before looking at the architecture, we'll take a look on some of the various terminologies that we'll be talking about on the architecture. The first being the cluster. What is this thing cluster all about? So a Kubernetes cluster consists of a set of machines called nodes that run containerized applications. What do I mean by this? Meaning that if, let's say that you have a server and you want to use it to launch your Kubernetes on it, it means that once configured, it becomes a cluster. Like once multiple of those servers are configured in a Kubernetes manner, it becomes a cluster. In that light, if you look at the diagram on the right-hand side, you see you have a cluster master, which is in purple. Then you have node. There you have node again on the other side. Let's forget about pod. We'll talk about pod and containers. But I just want to let you know that this cluster master is a server on itself, like, you know, the Linux servers like Ubuntu, CentOS. It can be an AWS instance, let's say Ubuntu, an EC2 like Debian, Fedora, so on. So all of those combined together is what makes up a cluster. Now, looking at this, we'll also look at another concept, which is known as the master-slave architecture. Kubernetes follow the master-slave architecture. What does that mean by the master-slave architecture? So in Kubernetes, let's say that you want to launch 5 servers or 5 instances, and you want to configure Kubernetes on those instances. What happens is that you have like one main master node, which is known as the control plane, or you can refer to it as a master node, or you can refer to it as a cluster master. The reason why it is referred to by that name is because of the configuration that it carries is just there as the father of all of those other nodes. Node, like I said, is what we refer to as servers in Linux, but in Kubernetes term, we refer to these servers that have been configured in Kubernetes as node. So we were talking about the concept of cluster master, which is also known as a control plane. And we are saying that it oversees the other node because that is where all the configuration as far as Kubernetes is concerned is done. And once the configuration is done there, it distributes the workload on the various nodes. Now, looking at this architecture, we can say that Kubernetes cluster has at least one master node and multiple worker node connected to the master node. So that means, like I was explaining, the cluster master, which is known as a control plane, oversees the other node. Looking at this diagram, you see the arrow pointing to the both node, meaning that once the configuration is done at the level of the master node, it is being integrated to the other node. So there's a connection that happens at that level, which we're going to see when we're setting up our Kubernetes cluster. But for now, I just want you to understand these terminologies, this concept, and we can move forward as we continue. All right, so looking at some of these various terminologies, like we said, there is another one known as nodes. And what is this term node? Nodes are machines that perform the requested tasks assigned by the control plane. In the company, nodes are huge servers. Like I said, in this concept, we are looking at node as the worker node. not as the node itself. So we're saying that we have the cluster master here and we have the node here. So once this has been configured, which is like the father in this cluster, what happens is that the father distributes the load or the work to his children. So the children here, we're referring to the worker node. That's why we're talking here that node are machines that perform the requested tasks assigned by the control plane. The number of nodes depends on company's environment and need. Each node has a kubelet kubeproxy container runtime running on it. We'll look at those terminologies again. So I hope that the explanation is becoming clear for some people that have been always finding it difficult to understand what Kubernetes is all about or where to get started with Kubernetes. I bet you this is the right place for you. You will enjoy it. Just stay put. I know this is a lot of material, but I know you'll get to it. All right, let's continue. So we'll continue by looking at what kubelet is all about. So this is a Kubernetes process that makes it possible for the cluster component to communicate and execute some tasks. Kubelet runs the application, but the control manager actually checks if the current number of applications running matches the desired, which is like the watchdog. So here, what we're saying is that we have a Kubernetes cluster. We have a Kubernetes architecture here, which in this case, we are saying that it has the cluster master, the node, and the two node. Here we're saying that with kubelet, it is actually a process that is running on each of these nodes. It is a process that is running on each node. And when any task is being given, it goes to the control manager, which we're going to see in a bit. I don't want to confuse you, but I just want you to just follow up along. So once a task has been sent, it goes to the control manager, then the control manager will tell the kubelet to execute the task. So this kubelet is being installed. It's a process that once installed on each of these nodes, you can use it to schedule your tasks, which we'll see in a bit. We have the kubeproxy, which maintains the network rules on node, which allows network communication to your port from network session inside and outside of your cluster. So as far as network is concerned, the kubeproxy is responsible for that. And we also have the container runtime. And in this case, we're talking about a software responsible for running containers, such as container D, CRIO, Docker, and others. So I know most people are familiar with container D and Docker. All right. Let's look at some other terminologies. We have, again, here, we're saying that each worker node hosts the pod that are component of the application workload. So a pod is the smallest and simplest Kubernetes object. A pod is set of one or more containers deployed to single node. Depending on how the load is distributed, you may have different numbers of containers on various nodes. So what we're saying is that we have our node, just like we saw up here. And in those nodes, we have a pod that are running. And what are we saying that these pods are? We're saying that pods are the smallest unit of Kubernetes. So that's what you can refer to as pod. And what is a replica set? It's a number of pods you want to deploy in a node. Let's say that you have a pod, then you want to deploy 10 of those same pod. What happens is that using a replica set, just like the term replica, you can replicate those pods as much as you want. It all depends on a company. Okay, we'll look at the control plane, like we said, that it manages the worker node, and the port in the cluster. And then we're saying that in production environment, the control plane usually runs across multiple computers. Cluster usually runs multiple nodes, providing fault tolerance and high availability. A master node has various Kubernetes processors running that are absolutely necessary to run and manage the cluster properly. And we're saying that in a master node. And like I said, another name for the master node is control plane or master node, or control plane or master node. And we're saying that in this master node, we have 4 processes that are actually running in this master node. The first being the API server, the second being the control manager, you have the scheduler, and we have the etcd. We'll look at them one after the other. Now, the API server, like I always say, I know this is now telling you, like, it actually bringing out the Kubernetes architecture. So let's say that you're in an interview and they ask you to explain the Kubernetes architecture, how it looks like. This is where you actually concentrate and pay more attention on, because it actually explains what Kubernetes is all about in a summary. The API server is like the gateway to a Kubernetes cluster. Before you even get to any Kubernetes cluster, you must first hit the API server. Like I always tell people, look at the term API, like the term API, application program interface. Be it in AWS, Google Cloud, whatsoever. Once you hear the term API, it just lets you know that it's a gateway to a server or an application or something. In this case, we're referring to an API server as a gateway into a Kubernetes cluster. So it ensures that all machines in the cluster can talk to each other. So that is the work of it, an API server. Then we have a control manager, and it keeps track of what is happening on the cluster, just like the name control, and watches the state of the cluster, then makes or requests changes where needed, make tags to ensure the state of the cluster matches the desired state. What do I mean by that? So we explained about the API server, and we said that it is the gateway to a Kubernetes cluster, meaning that whatsoever information or request that is first sent, first hit the API server, then is being communicated to the Kubernetes cluster. Then we're saying that another component, and very important component, known as a control manager, is a process that actually watches the state of the Kubernetes cluster. When I talk of state, I mean, let's say that the cluster is short of some resources like the CPU, like the memory. What happens is that the control manager is in alert to make sure that if there is any shortage as far as CPU is concerned, then it talks to the API server to see how the resources can be added. Okay, then another very important component is a scheduler, which is responsible for scheduling the various containers on node based on workload and available servers resource on each node, and Kubernetes actually does the task by allocating the resource when necessary to this ensure running of the application. So now we saw the control manager as it controlling the entire cluster, making sure that resources are needed at all time. And the resources actually meet the required state of the cluster. Now we're looking at another component of this architecture in the master node, which is known as the scheduler. And we're saying that it is responsible for scheduling request to various nodes depending on available servers and resources on those servers. And it does this by talking to the kubelet that actually does the actual scheduling. Remember when we're talking about kubelet, we said that it is its work is to allocate resources, or with the help of scheduler, it helps in allocating resources when necessary. Then the last one we talked was the etcd key value storage, which is a Kubernetes backend store that holds at any time the current state of the cluster, config data, status data of each node, and each container in the node. You can easily recover the whole cluster using the etc snapshot. This stores the desired state. So we're saying that any storage you want to do as far as the Kubernetes cluster is concerned can be stored at the etcd. All right, so let's look at this very good Kubernetes architecture that actually summarizes everything that you need to know. So looking at this, it actually tells you what happens in a Kubernetes cluster. Let's say that a developer, we all know who a developer is. It is someone who is actually writing the code. This developer can be anywhere, be it in Asia, in Europe, in the Northeast, or whatsoever. So the developer is here actually writing the code. So what happens is that this developer develop a code, and the developer sends a request that he wants to deploy an application, let's say Nginx, on port 80 through HTTPS. What happens is that this request is being sent to the API server. Remember that where is this API server? It's in the control plane, which is the master node. So the API server is a gateway of the application. Normally, we all know that it first should hit the API server. So once the request has been sent to the API server, what happens is that the API server will take that request, since the etcd is the storage mechanism for this cluster or for this master node. It takes the request and store it first in the etcd. Once it has stored that into the etcd, what happens is that the API server then talks to the scheduler, which work is to do the actual scheduling. The scheduler now, with its own role, which, like I said, is to schedule the resource or the request, would now check on the available node, because Kubernetes have this default way of knowing what node is free or what resource is free, then decide on what node to send the request to. So let's say that this scheduler decides to send the request to node 1. On node 1, the request is being sent, and through the use of the kubelet, the kubelet does the scheduling. So now, once this is scheduled, we have what is known as the control manager, and the work of the control manager is then to check the whole cluster to make sure that the state of the cluster or the resources that the cluster is actually using is currently what is needed for the cluster to run, meaning that there is no shortage of resources like CPU or memory. Now, if you look at closely, you see that Docker is also installed. And we said that Kubernetes is a container orchestration, meaning that it is managing containers. And in this case, our container here is Docker. And we're saying that this Kubernetes cluster is managing Docker containers. Then we also saw port, and we saw that ports are the smallest units in a Kubernetes cluster. And in this port, we have containers, and these containers are Docker containers that are actually running in this port that you see here. All right, if you look critically again, we have a more explicit diagram here that actually does the same explanation, but in a more deep and understandable manner, which I will see explain again on the second diagram. It's very, very crucial and very necessary for you to know how all of this work. Now, if you look critically, you will see that we have the user interface here, we have the kubectl here. And what we're saying is that the kubectl is just a way of a command line interface where you actually type command. Like in Kubernetes, if you want to type a command, you start with kubectl. Some people refer to kubectl, some people refer to as kubectl, or some people say kubecontrol. So anyone is fine. Then we're saying that in the Kubernetes master node, we have the API server, we have the scheduler, we have the control manager, and the etcd. And as you all see, all of these that are interconnected with the node. You see here in the node, we just have two nodes. It doesn't mean that you can have just two nodes. in a company environment, depending on the company, some have like 6 nodes, some have like 7. It all depends on the resources. But you see on each worker node, you have a pod, or you have multiple pod. Here we have 1, 2, 3 pod. You can have as many pod as possible. Then you also have kubelet, which actually help in scheduling tasks with the help of the scheduler. And we have the kubeproxy for network. Then we have Docker for container runtime. And all of this is same here. Even you need Docker is installed on the Kubernetes master. So what you need to note is you must always have a backup of your master node at any time in production environment. You should have at least 2 or more master node. Why will you have at least 2 or more master node? The reason being that if this master node goes down, the entire Kubernetes cluster is down. And we don't want that kind of a situation. So because of that, we need a backup of this Kubernetes master node. So in setting up of your Kubernetes cluster, you might start with a one master node, but with time, once this is done, you can also add another master node for high availability and fault tolerance. Is very, very necessary as this is concerned. So thank you so much. I will end here for today. Tomorrow or another time, we'll look at some Kubernetes features and Kubernetes features, which is really long. I don't want the video to be too long for you to find it difficult to understand. So we'll be covering this in another record. So thank you so much for watching my video. I really hope that this was really explicit enough for you to understand. See you on my next video when I'll be setting up the Kubernetes cluster and also explaining some of these most important components as far as Kubernetes is concerned. Please do not forget to like, subscribe, and share. Thank you so much, and bye.